Assalamualaikum. As you know from the previous class, we are discussing the inverters, that is DC to AC inverters. In the previous class, we have discussed several the contents of this chapter, and we have discussed the inverters and its applications and the difference between the source and voltage source inverters and current source inverters. After that, we have discussed single phase half bridge and single phase full bridge inverters. Today we are going to discuss three phase inverters. Let's take a little review. We already know that it's a DC to AC conversions, and there are several techniques and types, that is current source and voltage source. Applications, you already know the applications, that is UPS, high voltage transmission lines, and adjustable speed drives, and there are uh, based on the classification, method of connections, and so nature of the DC source. There are two types: voltage source and current source, which is the prime focus, and serial, parallel, and bridge type. There is a difference between already. We have already gone through this. Actually, our focus is basically on the voltage source inverters. Then we have discussed in the previous class half bridge inverters and full bridge inverters. Half bridge inverters involve two switches with the load, and at one time one switch will operate, and switch current and the load current follows the same chain. Similarly, when the other switch operates, the direction of the current through the switch is the same as that of the S2 is the same as that of S1. However, the direction of the current through the load inverted, and so does the voltage through the load. Similarly, this is very well explained, and if we connect a very highly inductive load, what will happen? It will smooth out your output current. As you know that the inductor won't allow to change the current abruptly, so it will be smoothed out like it is a triangular waveform. And in the case of full bridge inverter, you are involved with four switches, and at one time two switches are operating. You can see that this is a path, and here is the current through the switch 1 and 2, and here is the voltage across the output. And similarly for the next cycle, this is the current through switch 3 and 4. However, the voltage across the output is inverted based on the direction of the current through the load. Similar thing happens in the next cycle, and unfortunately this one is missing. Okay, for the RL load, you can see that for a very highly inductive load, what will happen? It will, this is the direction of the current through the D4 and DZ when it is conducting, and since highly inductive load won't allow the current to change abruptly, so it will be triangular shape. This is another shape. When D and D4 is conducting, then D1 and D2 is conducting. Okay. Now next is three-phase voltage source inverter with 180-degree mode. You need to be very careful in this understanding. What will look at the circuit first? You have connected a capacitor. The role of this capacitor is to maintain the voltage across the inverter circuit. These diodes are used for the protection purposes: D1, D2, D3, 4, 5, 6, and these are the IGBTs: T1, T2, T3, T4, T5, T6. You know that the IGBT has a superior characteristics as compared to BJTs and FETs, most FETs, because it combines the best things among it. There is some issue actually. BJT has limited switching frequencies, and however, MOSFETs has a high on-state loss. Both of these things are compensated in IGBTs. This is a star connection, and we can see that from T1 and T4 in between, it is connected to R, and N is the neutral point. There are three equal impedances. Okay, let's keep moving. This is the firing sequence. Mm, When T1 is fired, then it is related to the two firing angles like T5 and T2. The next cycle, it will be arranged like that. Similarly, T4, in the next cycle, then it is related to T2 and T3, and in the next cycle, it will be related to T3 and T6. Similarly, if T1 is fired, again the cycle repeats itself, and it is related to T2 and T5. Similarly, T5 is related to T6 and T3, and it's same as the next cycle. It is going to repeat it again. You can see from here T1, and it is discussed phase by phase. T1, T4, T3, T6, and T5, T2, T5, T2, T3, T6. How they are going in conduction, how they are going to conduct, वो कैसे conduct करेंगे, ठीक है. Let's see the diagram again. Each pair, ठीक है, ये pairs को describe किया गया है और इनका कंडक्शन एंगल ऐसे सेट किया गया है कि ये 180 डिग्री के बाद ये कंडक्ट करें, ठीक है. स्टेप वन में क्या होगा, as the suggest T1, T5 and T6 is conducting. You can easily see from the diagram. This is this is drawn for the simplicity. In the first pair, T1, T5, okay, and T6 is conducting. We will see one by one again. And in the next pair, T1, T2 and T6 is conducting. Go back and look at the T1, T2 and T6. T1, you can see that, T6 and T2 is conducting. From each of the leg, one is conducting all the time. Okay, that's pretty important. The understanding is important actually, how this is going to work. Similarly, the other pair, come back over here, T1, T2 and T3 is conducting. These are the overlapping regions. Similarly, if you go to T4, then T2 is conducting, T3 is conducting, T4, T5 is conducting, T3 is conducting, T4, T5, T6 is conducting. These are the thyristors or your IGBTs. And similarly for the next cycle, T5, T1, T5, T6, T2, T1, T2, T6, T1, T2, T3. These are the sequences. Okay, this we just go for these two, because next is just the repetition of the replication of the. This is actually 6 steps. You already understand. T1, T5, T6. This is the first sequence as T1, T5, T6. Okay. Similarly is the case T1, T2, T6. T1, T2, T6. Okay. And T1, T2, T3. T1, T2, T3. This is a conduction sequence. Okay. Let's move a little bit further. The step 1. Here is the diagram. You need to be very careful. Look at the previous diagram. T1 is conducting and T6 is conducting and T5 is conducting. The diagram is ultimately look like this one. लेकिन ये अगर आप और से डायग्राम को देखें और स्विचेस वो जो डायोड जो आपके एरिस्टर IGBTs कंडक्ट कर रहे हैं उसको क्लोज करें तो आपका सर्किट जो है उसकी ये शेप होगी एंड अल्टीमेटली इट लुक्स लाइक दिस वन और अल्टीमेटली आप देख इसको थोड़ा सा सीधा कर लें you know that in this kind of connection it's R and P with respect to neutral they are in parallel and it is in series with this these two are in parallel and ultimately it is in series with this Y connection and if we take the resultant of these two this is our VS and if we apply a voltage division rule these two are in parallel and for the parallel combination you already know that how to get this one in the parallel if you take the parallel combination you know that 1 over Z equivalent is equal to 1 over Z plus 1 over Z that is 2 over Z and Z by 2 and similarly this is Z and if you apply a voltage division principle then you know that this impedance is half than this one, okay, and you know that two times the voltage will be appearing across this one and one time is appearing across this one. If you add up these two you will get the total source voltage. I think you need to understand this point very carefully. In the parallel the impedances are going down and when you apply voltage division principle two times voltage will appear across this Y to Z and Y to neutral and the rest of the because these are two in parallel same voltage will appear across this one. For next VRN the voltage is Vs by 3 as we have already computed this one. Similarly Vyn we already know that okay this is also very important. You need to be careful about the polarity. If you are taking Y is the reference point then against your reference point this is negative. Okay, against your reference point this is negative. And you point. Let's discuss the next point. The next point is VPN, which is the same as Rn. Okay, R is just a reference point. It is from the neutral. It is from that point to the neutral point. Okay, this is a star connectivation. Okay, I think you have understood this very well. We need to be careful. Okay, just the point of care is this point, and we are y. If we took the from here to here, this is the total source voltage, and if we take the VYB, this is from this point to this point. This is minus Vs. Now you have taken your reference to this point, okay, so that when you take the reference like that then negative sign will be there and VBR if you took the voltage from here to this is the short, it is 0. You know that the short circuit is treated as 0. Now there are 3 points and we have measured the line to neutral. These are the line to neutral voltages. This is line to neutral, and this is, you can also call as, these are the line phase voltages. Sorry, these are the phase voltages, and these are the line voltages, line to line, RY, YB, VR. These are the line to line voltages, and this one is the phase voltages. We keep, okay, we already know that the phase voltage YN is, and in the step 2, okay, let's, where 1, 6, 2 is conducting, what will happen? Actually, 1, 6, 2 is conducting. We need to draw the equivalent circuit first. You can see that in this case 1 and 6, you have point, these two, they are short. Y and B point, they are connected to the same point, as you can see that, and it is connected to the negative terminal, and one is connected to the positive terminal through the R point. It's clear? I think it's clear. And similarly, if we, with the reference to the previous figure, if we are going to compute the values of the line voltages and the phase voltage, first of all we are going to, yeah, same scenario, the impedances in parallel, they will be halved. And when we apply, going to apply a voltage division rule across these two, since this is half, then this one, then the voltage is divided in 3 parts. 2 will be appearing across this phase R to N, and the rest of the 1/3 is appearing across this Y to neutral and B neutral point. Oh, let's write down these things. VRN 2 Vs/3. Similarly, VYN, this negative sign is due to the just the change of the reference point. If we are taking YNY, then it is positive since we are taking this one, and similar is the case this one. Now we have defined our phase voltages RN, YN and VN. Let's go for the line voltages. RY, you already know that this is the total voltage, VS. Let's keep moving, and next is our YB. This is the short point. Now the short circuit is always 0 volt, and VBR, from here to here, this line voltage is, you can see that this is a negative point. We can clearly check that, and the reference is negative RY, YB and VR. RY, YB and VR. This is kind of a clockwise sequence. You can easily remember this one. The line voltages are taken in a clockwise sequence, RY, YB and VR. Similar is the case in the previous slide. This is also taken in the clockwise sequence, RY, YB and, okay, just you need to be careful about this very simple point, and you have this is your phase voltages and these are your line voltages. Principle is same. Okay, now for each step we have computed the values of phase voltages and line voltages. These are the line voltages and these are the phase voltages. for the step 1, where which one is conducting, which one is not conducting. You know that at time 3, conducting one from each leg of the circuit, T1, T5, T6, like that. And from that calculation, we have repeated just 2 cycles, and we have seen that uh, these are the phase voltages. Two phases are Vs by 3, Vs by 3, and source voltage by divided by 2, and one phase is always 2 Vs by 3. Okay. Similar is the case. The previous slide you have already seen that. And if we take on computing these two, and your out phase voltages for each sequence of the conduction for T1, T2, T3, T4, T5, T6, you will have a similar scenario. We have just taken the example 2 steps and go ahead. Now time to plot these two. This is the phase voltage. We are, well, you can see that in step 1 we are is Vs by 3. Okay. Then it is 2 Vs by 3, and then again Vs by 3. Okay. Let's see how it is going to be plotted. This is Vs by 3. This is sorry. Let's go back and see how it is going to be plotted. Okay, Yn. Okay, they have started from here. Actually, from step 2, you carefully look at that VRN. It's a sequence actually. It is, if you look at this one, this is 2 Vs by 3, this is Vs by 3, then it is 0. Similarly, correspondingly, if you look at this one, then Yn, your Y phase is minus Vs by 3, and this is 2 Vs by 3, this is minus Vs by 3. And similarly, the next sequence is, if you look at, this is also minus Vs by 3. Yeah, same. And for the next sequence, if it is Vs by 3, then the other one is also Vs by 3, then it is minus 2 Vs by 3. Look at this one, Vs by 3, and is also Vs by 3, and this is minus 2 Vs by 3. Go back and see the next sequence. It's quite interesting if you follow it step by step. In the next sequence, you can see that it is minus Vs by 3 and 2 Vs by 3. Minus Vs by 3. This is minus Vs by 3, and Yn is 2 Vs by 3, and this is minus Vs by 3. Then you can minus Vs by 3, 2 Vs by 3, and minus Vs by 3. Similarly is the next one. In the case of Yn, now you are over here, and this is minus 2s by 3, Vs by 3, and Vs by 3. 2 Vs by 3, Vs by 3, and Vs by 3. If we go on repeating the last sentence, you can see that R and Y phase is minus Vs by 3, minus Vs by 3, and last one is 2 Vs by 3. Look at this one, minus Vs by 3, minus Vs by 3, 2 Vs. And if you look at the first sequence, that will be repeated Vs by 3 and minus 2s by 3, and look at this one, this is Vs by 3, minus 2 Vs by 3. Now we are over here, and Vs by 3. This one is this one. Okay, the first one is the last one, and actually it comes from here. It should be here, but you can start from anywhere depending on your situation where you are. Okay, it's a pretty simple idea. You can easily construct this diagram from this table, and this table can be constructed by following a sequence of conduction from these 3 pair of thyristor from the link. I think it's very pretty clear now. how you are going to construct the output. This is a phasor. And how about the line voltages? In the case of line voltage, we should have a table over here, but we couldn't do that. It's your assignment. You just construct a table. Okay, we have it. Line voltage. Okay, we have a step one. Actually, we have started from step two. R and Y is minus Vs. And Y R so Vs, Y is Vs, and B is 0. Yeah, S 0. And this is, you already know that Q1 or T1, whatever it is. And there is always a conduction of 60 degrees. You can see that if Q1 is conducting, you have R phase over there, and then for 60 degree, since it's a 180 degree, we need to consider 1. This is Q1, and if we suppose it has a relation, you can easily construct those from here. Okay, since it's a 180 degree voltage source inverters, it's a conduction sequence of one, and you can see that each thyristor, when it is conducted, it is conducted for 180 degree. I hope this lecture is clear to you. This is extreme importance. This lecture is of extreme importance. You can see that from this table, you can construct this phase voltages and line voltages without any confusion. Okay, I hope this is going to work for you, and you can one by one Q4, Q5, and you can take from step by step from that table. You can construct this one. Thank you very much.